Can you all see my whiteboard?
No.
Yes, sir.
You can see
Yes,
my
sir.
whiteboard. Okay. So you need to have your graph books, huh? But maybe today you make use of them during the homework that I'm going to give you. So we're going to look at transformations, a very important topic. Okay, transformations. You said, oh, you can see my whiteboard. That's good. So we're going to start transformations. That's what we're going to look at. So hold on. And can you hear me clearly? Especially those that are joining for the first time. Can you hear me clearly?
Your voice is a little bit muffled, but yes, I can hear you.
Oh, yeah, my voice is low. Okay. You lose someone there? Might have lost someone. Okay. So let's start. In general, or maybe before we even start, we've got 4 types of transformations that we need to know in a syllabus. So we have 4 types of transformation. I said transformation as a topic. So we've got 4 types only. We are required to know reflection. We are required to know rotation. Then enlargement. Can you see my whiteboard? So you're required to know reflection, rotation, enlargement, and lastly, translation. That's all for a syllabus. Translation, rotation, enlargement. Yes.
Sorry, sir. Could you just give me permission to record the lesson, sir?
You can't see.
No, I want to record the lesson, sir, and it's asking me for permission. So please, could you?
Huh. I didn't give you permission. This. Well, I can't.
Yes.
Wait.
Right click on my name, sir, and then.
Okay. Who am I speaking to right now?
Kieran Law.
Okay, wait a moment. Said if I right click on your name there, I should be able to see that.
Yeah, then it would say, then it'll say allow access or something.
Okay, hold on. This is technology. Okay. Yeah, I see your. Let me see. Allowed to record. Oh, I didn't know that. Okay.
Yes, sir, thanks.
Okay. Anyway, though I was recording this, I didn't know that there was also that option. Okay. So, yes.
Please allow me as well.
So I should just allow. I wish there was an option to allow. Oh. Okay. And who is that who wants to record again?
The
Takuza from Triangle.
kids.
From Chirez.
Yeah.
Okay. I have allowed you there. Okay. So are we all together? Transformations. It's all about Lila here there.
Yes, sir.
Okay. So transformation is all about 4 types of transformation: reflection, rotation, enlargement, and translation. Okay. We are going to start with this reflection. So reflection has got a mirror line. If I'm reflecting something, I think of a mirror line. I'll just show you just now. So reflection always has a mirror line. It's the easiest of them all, I think. So hold on. So there. So saying reflect this shape using this dotted line as a mirror. So let's start from there. This is our mirror here. So if this is our mirror, this image comes that side. Are we following, Takuzo? If this is your mirror, so what with the reflection now, if it's a line straight like this, since this point here is only one box away from this, it comes exactly on this. Are we together? Then this point here is how many boxes? 1, 2, 3, 4, 5. So it's exactly 5 boxes from the mirror. But remember I counted here, unless I didn't count properly. Sorry, 1, 2, 3, 4, 5. So it has to be exactly 5 again from the same mirror. 1, 2, 3, 4, 5. Makes sense? Then this point here is 2 boxes from the mirror. So this one will be exactly also 2 boxes from the what? From the mirror. 1, 2. Like that. Then this point here is 1, 2, 3. So exactly 1, 2. Sorry. 1, 2, 3. So exactly 1, 2, 3 comes there. Makes sense? Then of course you use a ruler. You draw your image. There I'm not going to use a ruler for the sake of time, my software. Then it will be exactly the same shape. Are we together there?
Yes, sir.
Now let's look at this. Apply the same because this is your mirror line there. So if this is your mirror line, this exactly the same distance away. This from the mirror, the same distance. Then this one is 1, 2, 3. So along the same line, 1, 2, 3 comes here. Then this point here is 1, 2, 3. So 1, 2, 3. Can you see that? Then you draw, you join your lines. I actually have a ruler here, but I didn't want to use it. But I might be forced to use it there. Then you use your ruler, of course, to draw. But there I'm going to avoid using it for now. But anyway, I can actually use it there. Make sense? Then you've got your shape there.
So,
So reflection is the easiest, no? Like what I said. Anyway, I'll simply use my free hand here. So that you get an idea. It will be, can you see we have reflected that? But now, according to your syllabus, I'll show you just now. What you're supposed to identify is the lines, the equations of the lines of the reflect this along the x-axis. Maybe we'll start from there. Along the x-axis. So this is your x-axis, huh? That is your y-axis. You know that very well. So if I reflect this shape, I'm sure you know that this is the mirror line. So this is a 1. Then this is -5, or in fact 1, 2, 3, 4, -4, 4 boxes. So that one comes also 4 boxes. 1, 2, 3, 4. Make sense? Then the last one there. 1, 2, 3, 4. So on the same line, 1, 2, 3, 4. Make sense? Then we have our reflected shape. Of course, you use a ruler. Are we together? But I will show you.
Yes, sir.
Okay. Now, this is what I was talking about here. Equations of light. So equations of simple lines. If I say the line y is equal to -1, y is equal to, it means the value of y always remains -1 on that line. Clear? Y is equal to -1. So if I pick a point here, what is the value of y here? It's -1. What is the value of y here? Is -1. Value of y here, value for y here is -1. What's changing is the value of x. So this line there that I'm going to draw, where is my rule? This line that I'm going to draw now is the line y is equal to -1. That's what you get now from your syllabus. Yep. Okay.
Would it not be easier just to freehand, sir?
With a ruler, I just wanted to show you. Okay, like this. All together. That's the line y is equal to -1. If it was x is equal to -1, it's a line like this, parallel to the y-axis. So now this is the line, and we are reflecting what? This. So if we are reflecting this, your guess for everyone is correct. Remember your mirror line like this. So we have how many boxes? 1, 2, 3. So it has to be 3. 1, 2, 3. So that first point there comes that point. Then this point here, it's almost the same. 1, 2, 3. So 1, 2, 3. I'm sure I see what will happen. Then the last point there is this point here, which is on 4, which should be from this point here. It's 1, 2, 3, 4, 5. So along the same point here to this point here, 5, 1, 2, 3. Then we need 2 more, 4, 5. Make sense? Then you've got your triangle. Of course, you use your ruler, you don't use freehand like what I'm doing. Are we together?
Yes, sir.
Now, look at this. Now we are not saying y is equal to 4. We are saying x is equal to 4. So x is equal to 4. If it was y is equal to 4, is this line here. Clear? X is equal to 4 is this line. So it means your ruler my ruler is now somewhat straight. Okay, I'm sure I get the idea. I wanted to show you. So that's the line, the middle line. Clear? X is equal to 4. So let's think of our middle line again. This point here, where does it come? But exactly, you use a ruler, it will come exactly there. I'm sure you can see that. Make sense? Then this point here is 2 boxes. So 1, 2 there. Then this point here is 2 boxes. So 1, 2 there. Then this point here is 1, 2, 3. 1, 2, 3. It comes there. Then the last point is there. Make sense?
Yes, sir.
Then you've got your nice shape. Of course, you use a ruler. That's your reflection. That's why I said this is the easiest, but sometimes you need to be able to identify where it becomes tricky. I will just show you now. Y is equal to 3. I'll skip this. I want to show you the other type of reflection that can give you all sorts of problems here now. That's where it becomes tricky now. The equation y is equal to x. So what it simply means with this equation is when x is equal to 2, look at this. When x is equal to 2, y is what? Is 2, huh? Because y is equal to x. When x is equal to 1, y is what? Is 1. When x is equal to 0, y is also 0, because they are the same. Okay, let's go to this. So you always start with the x. 1, 1. 2, 2. Follow me. 3, 3. I'm sure you can see the 0, 0. Our line. 4, 4, 5, 5, 6, 6. I think. Is that correct? Yep. Then let's use
Wait.
our ruler. Yes.
Sir,
Yes, your
I
question.
didn't understand.
Okay, I'll go back here. Now go back to this. Look at this.
Yes.
The equation is y is equal to what? To x.
-1.
No. Look at this equation here. Are you using, sure, there's no -1 here. It's y is equal to what? Everyone, can you see my whiteboard? I hope you can see my whiteboard.
Yes.
It's y is
Yes,
equal to x. It means the value of y and x are always the same for that equation. Remember, according to your Cartesian plane, you write the x coordinate and the y coordinate. So what I simply means is that if y is equal to x, when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. That's what it means. Huh? So if I write here and I say y is equal to 2x, look at this. If I say y is equal to 2x, I want you to follow me here. When x is equal to 0, what is 2 times 0? Is 0. Follow me. When x is equal to 1, it means 2 times 1, which is what? 2. When x is equal to 2, it means 2 times 2 here, which is 4. That's what I'm showing here. But this is simply a line y is equal to x. It means the value of x and y is the same. That's why I was plotting on 0, 0 there, 1, 1, 2, 2, 3, so that I can draw the line. Because there's no way I can reflect without drawing the what? The line. I hope it's clear now to everyone. Anyone with a question on that point? Then we draw our what? Our line. But now I'm saying that reflection is the trick reflection. Because it's no longer your symbol mirror of y is equal to or x, the straight lines. Huh? So this is a line like that. Huh? So how do you think we reflect it? How do you reflect it?
Yes, sir.
What do you think? Think of your mirror line. It's like that. I want you to think of a mirror. Remember, it's the same.
Yes.
Your image is going to, everyone will agree that the image is going to come there. But my first question is, where is point A going to be if a line is like this? Where is that point A here?
It's going to be directly over.
It's going to be at C, so isn't it? Because it's
3.
Look at this. This point will come this point. If the whole image will come this side. It can't be the same side of the mirror. It will come this side. But I'm saying where will be A there?
It will
So-
on 3. On
It will-
y. On
there.
3y and
You mean
2x.
there or where exactly?
3y and 2x.
You're saying?
3y and 2x.
Give me the coordinates. Remember, coordinates you write x, y. You don't start with the y. So give me the correct coordinate. Where will be the point, Lila?
2x and 3y.
2x and 3. So you simply say 2, 3. That's correct. Yeah? Why? Because when my line has to be drawn like this, like what he's saying here. So same distance here, it means this point here is exactly there. Is anyone lost there? Don't be shy to ask.
a little bit, sir.
So look at this. I'll explain to you. Everyone, I can't say one box and say one box here because this line is like this. Huh? It's not, if it was a straight line like this, then this point will be there. But it's not a line x is equal to 2. Brandon, are you following Tandy? Because this line is slanted like this. It means if I draw this line at an angle, a straight line like this all the way. This point here will be, see this distance here, will be exactly the same distance to that point here. That's where it came from. Which means I will try to do almost the same. For this one, I will do a similar thing here. So where would this line? I want you, who can tell me where this point will be? Let's see. Who can tell me correctly there?
G.
Sarah, say which point would D be?
Yes. I think D is on 2x 2 and 4.
2 and
2 and 4.
2 and 4.
Would it not be on 3 and 1, sir, over here?
3 and 1. Let's see his point. So his point is he's trying to draw it exactly like this. Then he's saying it will be exactly there. Anyway, Can you see that the difference between this and that is simply 1 unit? Yeah? So it should be also exactly 1 unit. That's very correct there, to be there. Because if you draw a line like that.
Yeah, thanks, sir.
Now, I want you to follow those are the 3 questions. B now, where will be B?
B.
Lie there, you're quiet. You
B,
see?
yes, sir.
No, she's
Yes,
there.
sir. Yes.
Now I was asking Lila, are you there? No, she can't hear us. Brandon, Tandy, where will be B there? Follow through. Try to imagine if you draw a line, huh? If you draw with the ruler. So where will be B? B, 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 B.
So it wouldn't be like on 4 and
Can I correct someone? I saw someone trying to put a point here. He's got an idea, but look at this. It can't be simply half one box here. Look at this. There it's cutting across this whole box, then it is cutting across one box. Huh? So if it cuts across half box, it has to cut
yes.
a complete box and come where? And come there. Is that making sense now? Lila?
Yes.
Yes, sir, it is.
Yes, sir.
And C, where will be C?
C would be.
You're almost done. Where will be C? Correct. Huh? So C will,
Oh, yes, sir.
you will be exactly there.
Oh,
Can you see that the image is simply the same? Huh? Although it has been moved like that. Huh? That making sense? A reflection. Huh? Okay. Let's look at another one. That is like that. Those things look interesting. Let's see what they're asking. Again, now look at this. Y is equal to minus X. Huh? What it means, someone I think can guess. Huh? Look at this. I want you to concentrate. So if 0 is 0, why? Because if I say minus 1 times 0 remains 0. Huh? Wait, now if I say X is 1, Y will be what line? It will be the negative. So Y will be negative 1. Huh?
1,
Negative
If I
1.
say 2, it means X is negative.
shift 2.
So like that. If I say 3, then this one is negative 3, like that. Okay. And we continue. Now, if we do the opposite, then okay. So let's go back so that we see what our line looks like. So 1, we said negative 1. 2, we said negative 2. 3, negative 3. Now, if it's negative 1, it's positive 1. The opposite. If it's negative 2, it's positive 2. So that you see how the line looks like. So that's all we need for now. We don't need because the shape is simply here. Okay, now let's try to draw a line. Then I need you to tell me what will happen to the shape. How do I do this again? Okay. Might have missed slightly, but it's fine. I'm sure you can. Okay, so can someone tell me exactly where will be this point? First point here, which is 2, 0, where will be that point here? According to this shape.
Yes, sir.
Yes. Where would be
It
that
would,
point?
it would be on 0, 2. 0 minus 2.
0. You said
Minus 2.
0 minus 2.
Minus,
This point here.
Yeah.
minus
Yes,
2.
sir.
Let's see. That's very correct. Yes. I agree with you there. Then this point here. Where would be that point? Maybe I have to remove it. Where would be that point there?
Mhm.
Because remember, it's cutting across 1, 2, 3. Huh? So it means if you were to draw your line like this again, it would be almost the similar whatever. We said 1, 2, 3. So it would be 1, 2, 3 along this way. Yeah. So where would be that point? To be also cutting across 3 boxes. Huh? Because if you were to continue this line, that's what I meant. You continue that line, cutting across this box, cutting across second box, cutting across. Remember, we said how many boxes here? 1, 2, 3. Follow me. Huh? Cutting across first box. Huh? Cutting across second box, cutting across what? Third box. Are we agreeing there?
Yes, sir.
Oh, we are not. Oh, it comes there. Where does it come exactly?
-2, -4.
Correct. It comes exactly on this point here. Then where does this one come? This point here? Reflection.
-2, -2.
Are we agreeing with her? She's saying -2, -2. Say yeah?
-2.
1,
Yes, sir.
2. 1, 2. Yes, there. That's correct. And your shape is simply the same shape. Like that. Are we together?
Yes.
Yes, sir.
Describe fully the single transformation which maps A onto B. How many marks? 2 marks. Huh? A onto B. So number 1, we can tell that this is a reflection. Huh? So to mention reflection, it's 1 mark. Huh? Clear? Reflection. Then what do we mention? Mirror line. What's the equation of the mirror line? Let's go and which one is the mirror line first before we even think of the equation? Which is the mirror line? Isn't it this one here? Isn't it the mirror line?
Yeah.
Look at this.
Yeah, that would be the mirror
That's
line.
the mirror line. Huh? Remember, we said these
Yeah.
lines, if it is this line is y is equal to -1. That's what I said. Y is equal to -2. So this line here is simply y. The x-axis is y is equal to 0. So it's the mirror line. Y is equal to 0.
0.
Because every point here, the y is 0. There. Clear?
Yes, sir.
Okay. Now again, you see, describe the transformation. So reflection, 1 mark. What is the mirror line? So reflection, 1 mark. Mirror line, what is the mirror line? What's the equation of the mirror line? Where is the mirror line anyway? Before we think of the equation. This and that. What you simply do is you
2.
count the number of boxes. 1, 2, 3, 4, 5. Clear? There are 5 boxes. Huh? 1,
Yeah.
2, 3, 4, 5. Then I divide them by 2 because it has to be halfway. Huh? So if I divide by 2 is 2.5. Huh? So 1,
5.
2. So it means the mirror line is like this. I hope you are seeing that. Huh? Not the way
Yes.
you're drawing. So it means if it's half of this, what is half of 1 is 0.5. Huh? But remember, these lines that are going like this are the lines x is equal to something. So it means the line x is equal to 0.5. Clear? If it was this line going, this is y is equal to 4, then x is equal to 4 is a line going up like this. So this is x is equal to 0.5. Then there, who can tell me that reflection? I know everyone is 1 mark. Now, what is the mirror line? We can find where the mirror line is there.
Yes.
Where is the line? You can guess, huh? How do you find that mirror line there? So if you look, this point here is cutting across
Negative.
this, cutting across. So can we agree that this is the mirror line here?
Yes, sir.
The same
Yes.
line that we said y is
Yes,
equal to
sir.
negative, y is equal to minus x. Huh? Are we agreeing there? Oh, it's y is equal to x. I'm lying. Huh? It's y is equal to x. Because when this is 1, this is 1. When this is negative 1, this is negative 1. They are the same. When this is negative 2, this is negative 2. So it's the line y is equal to x. Clear? The name y is equal to minus x is the line that goes the other way. Okay. Hope it's making sense now on the reflection. Now I'll skip this one now. I think there's some typing. So you see, they are now giving you the lines. Huh? Okay. See, let's do that together. Triangle A is reflected along the x-axis to give what? Triangle B. Huh? So let's do that. Along the x-axis, this one here. So it comes this side, huh? Because this is your mirror line. Huh? Are we agreeing? 1, 1 there, 1, 1. Then this one 4 comes in negative 4. We are agreeing now. So this is our B. Of course, you use a ruler. That's the first part. Then they're saying now what? B is reflected in the line x is equal to 1. And they have done the line for you there. X is equal to 1. So this comes that side. Huh? Are we all agreeing, Laila? So 1, 2,
Yes, sir.
3. So 1, 2, 3. Then this point here, simply 2. Oh, sorry. Did I count properly here? Okay, so this point here is 1, 2, 3. Okay. So middle line 1. Where's the middle? 1, 2, 3. Okay. Sorry. Let me just wrap it. So it's easy anyway. What you simply do is you simply do the counting like what you do. So our line, remember, we're not counting on 0. We're counting this line here is our middle line. This one here. So it means the first point 1 here, 2, 3. So from that same middle line here, that's why it becomes trickier because it's not on 0. So 1, 2, 3 there. Then this one here, it's from the middle line here, it's 1, 2, 3, 4, 5. So from this middle line, 1, 2, 3, 4, 5. Okay, follow me. This was the middle line is there. Then this one, this point here, from the middle line is 1, 2, 3. So from this middle line, 1, 2, 3, like this. Makes sense now? Because your middle line was not on 0, was makes. Are we together?
Yes, sir.
Okay.
Yes, sir.
You get 4 marks for free. So now they've given you a mirror line, huh? Which is y is equal to. Did we lose someone there? Who did we lose now? The other Takuzu. Okay. So our mirror line is this one here. Y is equal to 1. Huh? So this is your mirror line here. So it means if that is your mirror line, 2 boxes, 1, 2 comes there. Then this one, 1, 2, 2 boxes, 1, 2 comes there. Hope it's making sense. The last one, 2, 3, 4, 5. So 2, 3, 4, 3, 4, 5. Are we together?
Yes, sir.
Everyone, I hope we are still on the same page. Makes sense? The rest is
Yes, sir.
easier. So now we are done with what's left is simply to do questions, which I'll send to you. Now let's look at, was it an hour lesson? Up to half. Now also we'll do 2 of them. So we've looked at, now what you want to look at, the next thing there. Did we lose Takuzo? I think it's network, huh?
No.
The other Takuzo.
Hello, sir.
No, I'm saying
Yeah, my network.
you came back. Okay, yeah, back. It was your network, huh? Because I realized that someone had, we had lost someone. So then the next thing that we're looking at is enlargement. Enlargement. When we enlarge shapes, this one actually needs a ruler. It has no shortcuts. Enlargement. It's easy to tell, but now sometimes there are certain things that you need to know. So enlargement. Transformations. Oof, are we losing someone again? Oh, that was what's nature. It's giving him trouble. That's fine, I'll catch up. So I think we'll concentrate with the 2 for today. And I'll give you exercise. I just need to upload everything that I need here. My apologies. I uploaded the same page.
Yes, sir. How will we be doing the exercises?
I'll explain to you, don't worry. You'll be using your proper graph books, huh? You take pictures. I'll explain to you how you do. You do that. You convert to PDF
Okay.
and you send to me. It's not difficult. Okay, maybe I'll start from. Okay. Is Takus got the other Takus back? Not yet. Did he join back? I'm saying the lesson.
No, sir.
Oh. Okay, that's fine. Since we are recording, we will catch up. Okay, so I now have everything that I want. Then I'll show you the techniques for enlargement. Now, okay, that's fine. Just need to close certain pages. So enlargement now has got a center. I'll show you from this here. We're going to do 3 or 4 examples together. Clear, so that it will be clear for everyone. So you see this shape here. They are going to say enlarge it by a scale factor of what? I want to change this question here. So I want to change this question and then I'll explain this for now. So let's say here it's a positive. So I want you to see the difference. This is a very good question. So we're going to say scale factor here. We're going to change the question. Scale factor of positive 2. This is negative 2. Send out 0, 0. Clear now. So I said the first part we're going to do, then we do the negative together. Let's do the positive. Let me explain to you before I start here. Can you see my sender here? It's the origin. Everyone, are we together? Tandia there, except for
Yes, sir.
Utakuzu.
Yeah.
So if it's a positive enlargement, it's a +2. It means the shape will be twice as big as this one. But it will be the same side of the center. By the same side of the center, it means this same side here. If it's -2 like this, is the opposite side. It will come this side. It will be the opposite side of the what? of the center of enlargement. So what you do now, then I'll show you how easy that is. Your center is very important. So we have marked the center, then we take our rulers like this. So now when it comes to enlargement, rulers are very important. Sometimes you can do it by eye, but anyway. So what you do is you draw a line. Okay, I want everyone to listen there. From the center to every. So I'm concentrating with this point here. Can you see that this point here is cutting across only one box up to the center, like this? You're following me, huh?
Yes,
It's
sir.
it's one like this. So if it's cutting, sometimes you measure, but I'm showing you there's no need to measure. If it's cutting across one like this, because what's our scale factor is 2. What is 1 times 2? 1 times 2 is what? Is 2 boxes, huh? Yes. So it means from the center there, that distance has been multiplied twice. So it means this point here, without a ruler, comes there. Clear now? This first point here comes there. Okay, follow me? Now I'm going to do this point. Maybe I'll start with this point here. So let me use my same ruler there. Okay, I see what I was doing. Anyway, let me do this. Okay. Oh, it's the other way, or like this. Anyway. Okay, you now get this. So now look at this. So this is two boxes cutting across. Follow my ruler. 2 times 2 is what? How many boxes from this? What is 2 times 2? Remember, these are, what I mean is that one like this. I'm actually lying. Huh? Let's follow through. It's cutting across this box. It's cutting across this box. It's cutting across this. So it's 3 of them. Huh? So 3 of them, it means it has to cut across 6. Huh? 3 times 2 is 6. Huh? So I'm saying, but what I mean is 1, 2, 3, 4, 5, 6. So the point is where? Is there. You can see that the shape is being enlarged. Huh? Clear? So we have done the first part, which is there. We have done this second part, which is there. This is a 4-sided shape, huh? Because we have done this shape is there. We have done this part here. It's now there. Now we have to do this part here. This part we haven't done, huh? Clear? So this part here, I can use a ruler or I can do it without a ruler. Look at this. 1, 2. So it's going to cut across how many? 4. 2 times 2 is what? 4. So 1, 2, 3, 4 to come there. Makes sense, this part here. Follow me? Then this one here, if you want, we can use a ruler, but I'm showing you, I want to show you that we can do it without a ruler. So cut, if I had to draw a line, it was going to come like this here. Maybe let's use a ruler for this set here. Or some of you is still new to you there. So that I don't do shortcuts. Like this. Huh? Follow me? So you now have an idea there. Yep, okay. So, okay, I hope you are following me there. Okay, missed it slightly. Anyway, I'm sure I get the idea. 1, 2, that's what I meant. Huh? So because there are 2 boxes, remember enlargement scale factor is 2. So times 2, this point comes where? Because my ruler is not straight. Huh? This point comes here. Makes sense? Like this. So now look at our shape here. It's now a big shape. that making sense?
Yes, sir.
Making sense, everyone?
Yes, sir.
Okay. Now let's
Yes,
look at
sir.
where they said negative. Huh? Negative, I said, is the opposite side of the center of enlargement. Huh? So it means this point here is one box. Then this time it has to cut across what? If I was to continue this line, I got the other side of the center. So 1, 2, it comes here. Following me? Then this point here is along this same line here, but we said 1, 2. So if it's 2 boxes across times 2 is 4. So 1, 2, 3, 4. And comes there. Following me now. Okay. Now the other ones now are tricky. Maybe we actually have to use our ruler now, so that we don't miss it. But it's not difficult. So if we pick this point here, then it has to pass through every pointer has to pass through our center of enlargement. Takuzwa you back?
Yes, sir.
Okay. So Takuzwa here, we are doing enlargement. So, but you can follow through what you missed on the video recording. I'm also recording here. So, anyway, my ruler is not 100% perfect, but I simply want you to get the idea. So now, if it's, remember, it's negative 2, it will always come this side. So it's cutting across 2 boxes here. Along this line, there's to cut across 4 boxes. 1, 2, 3, 4. So I'm sure you can tell that it comes exactly there. Are we together? Then the last one, which is this one here. Remember, it has to pass through the center. Pass through the center. Like this. Yeah, I think his network is giving me issues. Yep. I know. Just need to. Okay, something like this, so that you get an idea. I'm sure now I have the idea. 1, 2, 3. Are you following me? But because my line has to exactly pass through. That's why I was trying to adjust my ruler here. Nope. So, what's happening here? Okay, I'm supposed to adjust it, but it's not supposed to move the other way. Anyway. Yeah, something closer. Anyway, you can now get the idea. 1, 2, 3. So remember times 2. 1,
Okay.
2, 3. Yes. 4, 5, 6. So you actually missed it here. What's your question?
So what are we doing here?
We're doing enlargement. Were you not there? We are doing enlargement. As I said, you catch up here. We are doing enlargement. Anyway, maybe let's start another one where everyone is there. We're doing enlargement here. Okay. Now look at this here. See, what's our scale factor? What's our center here? 0, 2. 0, 2. Follow me. This is our center here. Clear? Then what are we enlarging by, everyone? Minus 1 point what? 5. I want you to follow me. Minus 1.5. So my question to you is, this object, if it's 1.5, it means it's 1.5 times. It's bigger than this one because it's 1.5 times. Huh? But the negative means is this side, it's the opposite side. If it was 1.5, the same side, it will come this side here, and it will be enlarged. It will be the same side of the center. But because it's negative, it comes the other side. So remember what I said is you draw. So from this box, this is a straight line. There's no need for me to draw. From this point to the center. So how many boxes are this? 1, 2, 3, 4. This is 4. Can you multiply 4 by 1.5? What do you get? Remember, our scale factor here is 1.5. What's 4 times 1.5, everyone? Is that 6? Lila? 4 times 1.5 is what?
6.
6. So it means it's from this center, the other side, 6. So it comes here. Sorry. Exactly there. This point here. Are we together there? Following me? Then, the points that are tricky is this point here. That's the one that is tricky now. Because now we actually have to measure in terms of the centimeters. But anyway, I'll show you what you can do without measuring. Huh? Because now it comes the same, but now it's only tricky that sometimes on the same ruler you have to measure, then you multiply by 1 point what? 1.5. Huh? That's what I mean. So using your ruler, if you actually on a graph book, you measure this, then you multiply by 1 point what? By 1.5. Is that making sense? Because your scale factor is what? Is 1.5. But now I'm going to just to make a random assumption that if it was 2 boxes, maybe 2 centimeters, multiplied by 1.5, isn't that 3 boxes? Huh? If I'm correct. Are we agreeing? Or the teacher is wrong?
Yes, sir.
So 1, 2, 3. Okay, because we slightly missed the center there. Let's see. So I'm sure you have an idea there. I'm simply doing this so that you have an idea. 1, 2. So 1, 2, 3. Yeah. 1, 2, 3. So it means it comes exactly there. Are we together? You see how our shape is being enlarged. Now, so we're doing this one here, which means this one is the last one. Huh? So let's look at how that looks at. Very tricky. Okay. Can I show you another way you can do this without drawing this? Look at this. This one is 2 what? How many units are here? There are 2 units. Huh? Because these are on the same line, huh? It means even if I was to do enlargement, this point here are exactly on the same what? Same line. Huh? If there are 2 units, what's 2 multiplied by 1.5? Isn't that 3? It's 3, huh? Lila?
Sir.
Yes. So it means 1, 2, 3. That point there is exactly there. And this is your enlarged shape. Let's see if this is correct. This is 2 boxes. Yes, that's correct. 1, 2, 3. Can you see that? We've enlarged it by minus 1.5. Center. That. Okay. Don't worry, it's not difficult. Just needs you to practice. Some of these questions, they are not written properly anyway. Let's just check these ones on the past exam paper. Oops, sorry. Did I miss out my? Seems my Zoom session closed. What happened? Did I close it by mistake or something?
You might have just minimized it, sir, because we can still hear you.
You can still see it.
No, we can still see your screen.
Yeah, my screen is there, but I'm saying I lost my whiteboard software. Like,
Press hold Alt, and then press Tab.
yeah, it's not there. It actually
It's not
closed.
there.
It's closed. I don't know why it closed.
Oh, okay.
Actually closed. That's why I'm trying to reopen it now. Yeah, my apologies for that. It actually closed. Mhm. So we only have 2 minutes here. So what I want to do is I want you to send you an exercise. Then maybe Takozo have to follow on. You lost 1 or 2 things on enlargement. So I want to send an exercise on, because now we need to do ICT. I think if I'm following the timetable, I'll check this now.
Yes.
Yes. So Takozo, I'll send an exercise to everyone. But some of you are not in the group. I mean, we'll add you to the group.
No.
Then we'll
Homework
send
on the first day, sir.
Yes. So I'll send you a short exercise there. Then you have
Yes,
to use
sir.
your graph books. So for those that are new, once you do the exercise in your graph book, you take pictures of your work. So once you take pictures, then I'll send you the software. Maybe some of you don't do. Or on your phones, if you're taking your phones, I think they have got what they call, I'm sure the rest of the guys will tell you. I'm not sure whether they use, Takuza, what do you use again? Cam scanner or something? It takes a picture and converts to
Yeah,
PDF straight away. Yeah.
So you can just take a picture, and then when you transfer it, when you're sharing it, you can just transfer it to
No,
a PDF.
my software only marks PDF. So when you're
Oh,
sending to me, you send as a PDF. That's what I mean.
oh, okay.
So you convert those pictures to PDF. But now, for example, if you are doing 3 or 4, it's also easy now for you. You combine those PDFs. There are so many free softwares that combine so that you send as a one complete PDF to me, and it's easy for marking. Okay, that makes sense now.
Yeah.
Okay. So we are done for today. We'll continue.
Thank you.